Hello everyone, my name is Takla Hanna. Elizabeth and I will be talking today about how to prevent epileptic events using low-frequency stimulation. First, let's talk about what is epilepsy. Epilepsy is a disease of the brain in which abnormal electrical activity causes strong action potential that cause the body to seize, and sometimes it can cause a lack of control over the body. If we look at the picture on the right, you can see a comparison of the brain activity normally, partial seizure, which affects a specific part in the brain, and generalized seizure, which is affecting the whole brain. Epilepsy is very common in the US. It's the fourth most common neurological disease in the United States. In general, there's about 1% chance that epilepsy can occur in the US. On the individual level, epilepsy is very common in people under 20 due to birth difficulties and people over 65. Currently, there are pharmaceutical treatments for epilepsy, but even though there are still 30% suffers because they develop drug resistance, we look for a non-chemical solution. Alternatively, we can prevent epilepsy by activating GABA B and AHPS. So, what is GABA B and what is AHP? GABA B is a G protein coupled receptor. When it's activated, it increases potassium conductance through inwardly rectifying potassium channels. Then, calcium entry inside the cell decreases, which inhibits neurotransmitters from being released from the presynaptic cell. We are expecting that the low-frequency stimulus triggers a long-lasting hyperpolarization, which is mediated by that GABA B, will protect the inner stimulus period from any epileptic activity. So this is the first step. Second step, AHPS. It stands for slow after hyperpolarization. AHP has two main functions. First, it limits the firing frequency of the neurons. Second, it is responsible for generating a spike frequency adaptation as a response to a repetitive depolarization. Calcium influx during somatic depolarization activates the EHP. Therefore, it could enhance the EHP, especially the slow EHP, which is the other component of the long-lasting hyperpolarization that protects from epileptic activity. So, what are we testing? We are testing a non-chemical anti-epileptic alternative by activating GABA B and AHP. So let's move to how. Neuron program was used to model the DNA gyrus of a rat hippocampus, including the ion channels with 4 different cell types. Original model was developed by Morgan in 2007, and the following modification was made, or was attempted made. A low-frequency signal, which is 1 to 4 Hz, was implanted into the simulation utilizing an alternating injected current at the source of the epileptic events, in the same location as the origin of the seizure signal. The output should show action potentials during the epileptic model without stimulation and potentials during the epileptic model with the low-frequency stimulation. Further tests can be made by changing the location of the injected current, as well as the time at which the current is injected. So we can add a delay of 1 to 5 seconds to review the effects over time and see how is it going to affect it. Unfortunately, we couldn't get the program to work, so we only have the results from Morgan from 2007, which showed the epileptic event without low frequency stimulation, which is shown in the picture right here. We tried and we attempted the code that we have, but we had some technical difficulties. But we're expecting it will work as we have seen from other resources. Thank you for listening and have a good day.